Hi, everybody. This is Dave Lover, Aero Systems Integration. We're here with a cast of thousands. You're listening in on one of the cool hot topics. We mentioned in our email, we're doing a webinar series that talks about a lot of the things that are outside of sometimes our comfort zone, you know, of whatever industry we're in, whatever we're doing, whether it's communications, contact center, or otherwise. And so we have a whole series that we're going to do every single week. That's the goal. And yes, we probably are going to have to cancel some that conflict with Thanksgiving and maybe other holidays, but that's the goal. Every Thursday, same time, same channel, at 11 o'clock Central. So today we are talking about NEC's Neoface watch. It's a really cool product technology that NEC has that helps to create watch lists and find people in the crowd. And as you can imagine, there's a million use cases for that. And so we're going to talk about some of those. So first, a little bit of housekeeping before I introduce our panel. But if you have a question, feel free to ask that within the questions section. You'll have to type those in. Everybody is muted by default. And so just ask your question in that section, and we've got some people that will help answer those. And then we'll probably answer some verbally more towards the end of the session, or depending on if some interesting ones come up. So that's kind of the general idea. We are recording this, and we will post this on our website at some point once we figure out exactly where that's going to go. But you'll find this as a recording there, along with all of the rest of these that we do in the series. So with that, I want to introduce our presenters. Barby Biggs is one of our solution architects here at Aero SI. And she works not only designing and working with some of our largest customers, creating a lot of different communication solutions, but she also happens to be one of our Neoface watch subject matter experts. And she's joined by Jason Zartman, who is one of the product managers for Neoface at NEC. So we've got some cool stuff there. We've also got Daryl Blackburn, who is our channel manager, who helps kind of cut through all the red tape and help with some of the operationalizing of our business with NEC. So with that, Barbie, I want to turn it over to you and have you kick this off.
Great, thanks, Dave. And I just want to take time to say thank you to each one of you that joined us today. Like I said, Dave said we had a fantastic turnout. We can see that on the bridge. We are going to jump right into this and talk about biometric facial recognition. What is it? How does it work? We're going to talk through some use cases, some of the common ones that we see in casinos and hospitality, stadiums, border control, areas like that. So we're going to jump right in. And this was one of my favorite pieces to put together because it really shows what's happening today, and that there are cameras everywhere that we go. When I was doing the research, I actually came across a little tidbit that said that it's estimated that there are 30 million surveillance cameras deployed in the US now, and that those cameras are shooting somewhere around 4 billion hours of footage a week. So we're talking about the cameras that you're not seeing, or maybe you are, but when you're in the grocery store or you're pumping gas or you're visiting someone at the hospital, we're being watched almost all the time and everywhere. And if you live in an urban area, it's estimated that you come in contact with somewhere over 75 cameras a day, just in your normal daily activities. So our question becomes, how do we use those cameras and the resources and the information that they're capturing in today's enterprise? So biometrics, when most people think about biometrics, the one that comes to mind first is probably the thumbprint. And it's become mainstream in the last couple of years due to the smartphone. I mean, we don't think twice anymore when we put our thumb on our home button to unlock our iPhone. But because that fingerprint is a unique identifier, it's a great source for biometrics. But biometrics really means using the body's unique physical traits to identify an individual. So when we move past the fingerprint, we get into items like the eye or the iris. Each person has their own unique eye pattern as well as color. It makes that piece of ourselves uniquely identifiable. And then another item that we also talk about a lot is voice recognition, and how we can measure the cadence or tone in someone's voice. Another way that we can use biometrics in a recognition platform. But what we're going to talk about today, and what's most arguably the most complicated form of biometrics, is facial recognition. And that's because the facial features are so complex. So it could be the size of the eye, the distance between the eyes to the ears, the nose, where the mouth is placed on the face, and how that becomes a unique identifier in itself. So what is facial recognition? So let's pause and talk about that, because it's a natural human process. We do it thousands of times a day, and we don't even think about it. It's something we do quickly. It's something we do contactless. We don't have to talk to someone to realize whether or not we recognize them. But how many times have you met someone only to see them again and not be able to put a name to the face? I mean, it happened to me not too long ago. I was on an inbound flight, and I was standing at the luggage claim area, and across the information desk was one of my customers, and he was standing there, and he looked right at me, but I could tell by the look in his eye that he couldn't place me. And I knew it was because I was out of the normal element that he normally saw me in. I wasn't in a suit. I was casual. My hair was in a ponytail. But the point is even though we've been doing this for hundreds of thousands of years, it's still not perfected even in the human race. If you look at the two pictures on your right, you see two pictures of Tom Hanks, but they're different in so many ways and with different traits. We have young Tom Hanks, clean cut, and then we have poor castaway Tom Hanks. So the issues that we run into with facial recognition is, how do we make sure that we're capturing that that's the same person, whether he has a beard or that he's aged? There are a couple different ways that we look at facial recognition. The first one that you're seeing on your screen is really the simplest recognition that we talk about, which is a one-to-one recognition. So it's simply looking at a person and a document and deciding if that's the person. Maybe that's a driver's license for a police officer. Maybe it's a season pass when you're going into an amusement park. It's a one-to-one match. Is the person I'm looking at the person that's on the document? The next piece of facial recognition is when we look at a one-to-many match. So this is where it requires more processing power and more scanning within the technology, because you're looking at that single person and you're matching them to a watch list or a database that could have thousands of people in it, but it's still a one-to-many. It's the one person. So speed is important in this match, but when we get into what's really complex, we're talking about the many-to-many match. And this is real time, it's live, it may be a crowd walking into a venue. It's taking many faces that are being captured and comparing them against a large database, a database that you get to define who's in based on common attributes. When we start talking about many-to-many, it's where we require processing speed and power. This is happening in real time, and it definitely takes the hardware behind that to process that information. So what you're looking at now is an image of thousands of people walking down a street. And this is actually a challenging image, because if you look, you're going to start to see the little yellow squares pop up around people's faces. And what that's identifying is, out of all of those people, those are the ones that can be identified with facial recognition. It's a good frontal shot, you can see their face, but hundreds of other people are either turned away or turned sideways. They're not a good match. So when we start talking about this, we want to look at it in a mathematical example. And the example that we normally use is, let's say that a surveillance camera on this street is capturing 12 frames per second. And in each one of those frames, there's 5 faces. And then we're looking at those 5 faces and we're searching a database of, say, 10,000 people. So what Neoface Watch needs to do is actually a comparison that is 600,000 frames a second. And it needs to be able to execute that in an accurate fashion. So this is actually a small scale environment when we look at this, but the real world consists of deployments that could have 1,000 cameras in it. So Neoface Watch must be capable of looking at those 600,000 frames per second across all of those camera feeds. So if you do the math behind that, it adds up to a little beyond 2 trillion or 160 billion face comparisons each hour. And right now, the product that's on the market that can do that in the most accurate fashion is what we're talking about today, which is NEC's Neoface Watch. So when we were looking at that street and you noticed that we were only picking out certain faces within it, that's because those were the best images that could be captured. So when we start talking about camera placement, it's very, very important in the overall Neoface Watch platform. So we have 3 things to consider when we start placing cameras: pitch, roll, and yaw. So the pitch is a person who's facing forward, whether they're looking up or looking down. That could be someone who's looking at, a map on a wall. It could be someone who's looking down at their phone. So give or take, that's about a 20-degree pitch that puts in optimal range. The roll, which is someone leaning their head ear to shoulder, either right or left, that range is a little more, so you get a 40% range within roll. And then yaw would be that person looking from right to left. So that all comes within certain parameters that produce the best image to allow Neoface to work correctly. So we talk a little bit more about camera placement. You'll see the optimum camera placement designs on the slide, where we want to make sure that camera is not placed too high. We want to make sure that it's not placed too low. It doesn't run in the same parameters as a normal security camera because we're really trying to capture the face. So you can't expect that if you have a camera mounted on the second floor of a shopping center that it's going to get or produce a good image from someone walking on the lower level. So the slide shows the optimal placement to make sure that we get the best image possible from our cameras when they're deployed. Another key factor to consider is lighting. And if you look at the images, you'll notice that the image on the left is washed out. So it may be in an area where it's too sunny or there's reflection coming off of a window. The next image is too dark, or you could see an image with a partial shadow. Maybe that person is standing beside a window with something as simple as an office plant beside them, but it's producing a bad image to the camera because it's a partial shadow. And then the last image is a good image. Face forward, good lighting. It's the best image that we can hope for. One of the biggest challenges that we actually have in camera placement is what we call a west-facing window in the afternoon, where you have the sun shining in at the low angles. It starts to go down and it becomes very, very bright, producing a lot of that washed out image that you see on the left. So it's very important when we're doing deployments that we're measuring light or taking into consideration the light at different times of the day to produce that best image quality. And this is a very basic block diagram that references the architecture of NEC's Neoface Watch. And it's actually listed in very simple terms. But in the block on the left where we have capture, we are showing the IP cameras that may or may not exist in your environment today. If they do, those cameras normally feed into a security system, or they can feed into a security system or a video management system. That video management system would feed across your network. And this is another key piece to take into consideration. That network needs to have QoS on it, because if we relate that back to the world that we think of most often, which would be IP telephones, we're still communicating in real time. So the network tying together your video cameras needs to have that same quality of service. We need to produce quality images across the network so that they can be delivered to the database. So the database, which is in the assess and match category, is a piece of Neoface Watch. And what's in the database itself are customer created watch lists. And those watch lists are easy. They're people with common attributes, whether that watch list is created by you to be a VIP list of people entering your establishment, whether it's a whitelist or it's a blacklist of individuals who should be removed for whatever reason. Maybe it's a criminal record, maybe they've been removed from your property before, maybe they're unknown or they're an ex-employee and you don't want them there. That's how we create a watch list. It's those common attributes. So once that we've taken that image and we've moved it over to the database and we've assessed and matched it, the question is, what do we do with it next? And that's really dependent on each individual use case because we have lots of options. So Neoface Watch actually has a dashboard that you can look at live anywhere that you want. So if you had a security office and people were actively monitoring the camera feeds, the database could be on their desktop and it can pop alerts as to when someone matches a watch list. You can watch it in real time to show identified individuals as they walk through your building, whether it be an employee or a VIP. We can do simple items of notification as in sending an email or a text specifically to someone. And then the last and my favorite form of notification for me personally is the mobile device. So Neoface Watch has a mobile app for Android or iPhone that can send alerts to the application as they're identified by the system. And the other thing that that mobile app can be used for is for adding individuals to a watch list on a fly. So let's say that you're security within an amusement park and you're removing someone from the park and you want to make sure that person doesn't re-enter, not only that day, but maybe you've blocked them for life for a major infraction. Security can take a picture and enroll that individual into that watch list that you've deemed, be it 24 hours, 48 hours, or a lifetime ban. And it's instantaneous. So if that person actually went out the park and tried to come back in through a different turnstile and the turnstile caught their image, security could escort them from the park at that time. So it really does provide a wide range of notification capabilities, and they are user dependent. So you could have one, you could have all, you could determine who gets notified in what direction. So it turns out that there is actually a federal government agency, the National Institute of Standards and Technology, or NIST, that has a role in actually evaluating these types of technologies from different manufacturers. And it's their goal and responsibility to understand and benchmark the technology itself. The last NIST study that was completed is called the NIST 5. It was started in February of 2015, but the final report was just issued last year in March. And it actually looked at different manufacturers within the technology, and it looked at and put them through 3 different scenarios. So if you look in the bottom left, the first scenario was a simple jet bridge scenario, where this was a one-to-many comparison. So it was comparing the person that they were seeing to a database. That one's pretty easy, pretty simple, pretty standard. The next area of comparison, the sports arena, it was based off cameras actually placed at entrance points in common areas within the facility. So they were doing a real-time, many-to-many match on the people coming in and out of the event. And then the third and last evaluation that they did was a new one that was added where they actually used a red carpet scenario. So think about the Grammys. I apologize for that. Talk about the Grammys or the Oscars. And the technology was used to evaluate who should be on and who should not be on the red carpet. So whether that was identifying a star and knowing that that person was to be there, or it was looking for the person who wasn't in the database to be on the red carpet at all so that they could be removed, or lastly, it was also looking at people in the crowd to identify if any of those people were a threat. So they tested all the major players, and the next slide that we're looking at actually shows the results of those findings. So up the left side of the chart, you'll see the error rate based on that passenger gate, the jetway, and what we consider the simple environment. So the low matching accuracy is on the bottom, and as it grows to a smaller error rate, it goes to the top into the green. And you'll see that NEC and Neoface Watch was at the top of that list, where it was the most accurate in matching in that simple environment. But you'll also notice across the bottom of the chart is the difficult environment. So that was the many-to-many comparison. That was the sports arena where everyone was coming in the door. It was being matched to a large database. And you'll see that NEC's Neoface also scored well in matching accuracy in that environment, which really kind of puts them in what we consider that magic top quarter. And you'll notice that there are other players and where they were tested and where they come out on the list, and that there are many players that work really well in that simple environment, but as you start to move further over in the difficult environment, in the real-time many-to-many comparisons, that's where you see the competition really start to lag behind NEC, and that's why NEC is the leader for both simple and difficult scenarios. So then we want to talk a little bit about Neoface Watch and use cases. And some of them we're going to talk through are actually pretty simple, but I don't want you to think that this is the only way that the technology can be used, because it can be used within your facility in multiple ways. So defining the use cases we haven't seen yet, that's actually a challenge that I look forward to. But the first one we're going to talk about would be casinos and hospitality, because it's one of the easiest use cases to grasp, because generally we're looking at a good guy or a bad guy scenario. So the watch list could easily be built of bad guys, whether those are known criminals, whether there's a history of cheating associated with that individual, or maybe it's just people that have been thrown out and barred from the casino for numerous other reasons. A database can be created of those individuals as they're removed originally from the facility. So if they try to re-enter, again, they can be met at the door by security and escorted off the property. There's no reason to allow them back in and have someone try to identify them on a visual or a picture of an image that they've seen maybe earlier in the day as someone to watch for. We now have the technology to do that screening for them and not on that one-to-one. But in a casino and a hospitality environment, you could very clearly have a VIP list as well. Someone who would opt into that program, consent to having their photograph logged in a database. And maybe when that person walks into the front door, a notification is sent to the concierge service who meets them in the lobby, offering that degree and level of customer experience. So this is a real world example that I'm going to give you of a casino deployment. So NEC worked with a company who owned 10 casinos, and they did a really simple proof of concept in one of their casinos. They took one camera and installed it, and what they were really looking for at the time was they were looking at the technology, they were looking at the lighting, they were looking at the camera placement. But the thing that happened was within 2 days of installing that proof of concept, Neoface Watch actually identified a blacklisted individual.
Hey guys, I think we lost Barby.
Yeah. I don't hear on my end. I just received a text from Mark. He doesn't hear her either.
Okay. Let me work to get Barby back. And in the meantime, Daryl, would you be willing to kind of take over the session until we get her back? Or Jason?
Yeah. Either one. I can handle it.
Jason, go for it.
Right on. So everybody can still hear me, right?
Yes, absolutely.
So we were talking about casinos and hotels and bringing in watch lists and the VIP engagement. So we can turn those watch lists from a bad guy list into a good guy list and turn those into for VIP notifications. Those notifications, as they come into the building, we'll separate those out we'll separate out the alerts. So threat alerts, they'll actually go to the security personnel, and then the VIP alerts that are coming in, they'll actually go to the customer service personnel or the concierge. And the alerts that come in, they'll have the camera location, the enrolled image of the subject, and also the captured frame of that subject. So as you're the customer service rep and you walk over to that person, you'll actually know who they are, know what they look like, all from the alerts that come into your device. You can also be looking at monitor queue times and waiting lines as well. We have a use case running out at Houston International Airport that is deep into queue depth for international flights coming in. The TSA guarantees that the airport will get the passengers through the customs, baggage claim, and immigrations within a certain amount of time. So what we've done there is we've placed a camera as they come off the airplane. We start capturing the passengers' faces, and we start registering them into the database as passenger 127. We don't really care who they are. We're just marking them as, okay, this person's exited the plane. And then throughout that journey, we have a couple other cameras placed at immigrations, and then at baggage claim, and then customs. And then as that passenger goes through that journey, we can time him and see how long it's taken them to get through there. If it's taken them an hour or they're not meeting their contract numbers, the TSA can just start sending over employees to start taking that queue depth down. Or Houston International, they can also take that data back and report it back to TSA and fine them, or have them employ more TSA employees to the airport as well.
Hey, Jason, just so you know that Barby can still hear you, so if you need to advance a slide, she can still do that.
Okay. Well, let's just go on here with that's a little bit about queue depth. I don't think we touched on that, what Neoface can do with doing queue depth lines and seeing how long it's taken passengers or people to get through an event or journey. So we can go into, just go on to the next slide here with stadiums and event venues. This is also a great location for Neoface Watch. If you kick somebody out of your stadium, what do you do today? You mark them as flag person and they can't get in there, and you put a black and white picture in the break room, and everybody glances at it real quick, and they go on back out the door, and they start checking people in. They forgot about what that person looks like or who he is, so they're just coming on in. With Neoface Watch, that's all taken care of. You register them into the watch database for bad fans, and as soon as they're trying to get back into the arena or venue, they're immediately recognized, threats put out, alerts are ran, and they can take care of that and get him out of there as well. Yeah, so the soccer deployment, we have a great system running down in Medellin, Colombia, where there's two soccer teams in that town of Medellin, and when they had soccer events, one of the teams was playing, the other fans from the other team were not allowed to come into the arena. I guess there was just so much fighting between the two groups that they just said, okay, you guys are no longer coming in when one team is playing. And then, so we deployed Neoface Watch down there, and we enrolled every person that has a ticket into the Neoface Watch database. If you're a good person, though, you're not being watched in real time. You're just recognized and come on in. But the bad subjects, the people that are causing all the troubles, they're actually put into a threat watch list. And then as soon as those guys, those patrons come back in, they're immediately alerted, kicked out of the stadium, taken care of that problem. So that ran for probably about 6 months to a year down there. And now today, they're actually letting both the fans back into the arena. It's a really great story and use case of how you can use Neoface Watch to really put physical security on your property.
Hey, Jason, is there a chance you can hear me again?
Yes,
we hear you
again.
Yeah.
Sorry, I have no idea. I apologize for that, but thank you for jumping in and taking over. I think that we have one more use case which kind of feeds into an airport scenario, but
yep.
Airports and border control, right? And I think that one's a pretty easy one to understand, whether it's customs or homeland security, using Neoface to monitor people coming inbound or getting ready to board a plane. So that one in itself is pretty easy. And then the last use case that I had listed was actually the Houston airport, which you talked through, right? So that's all about flow control.
Yeah, you're right. Thanks. Yeah, sorry, I didn't know you had that in there. So also at Houston, I don't know if you were going to talk about this or not, is that they are also running a POC for passenger verification. They're taking the passengers, they're checking their tickets, and then there's a little kiosk there that captures the face and verifies the passenger with the tickets getting onto the plane as well there at Houston.
No, that's a great use case, and I didn't have it listed. But I think that as we start talking through these use cases, you'll see where the other options are. You know, maybe it's in an amusement park and it's used in double or triple duty. One of the customers that we're talking with right now has the option, of course, to use it as a way to verify their season pass users. But not only that, we've actually been discussing with them the active monitoring of Megan's Law. You know, it's a family-oriented facility, so the ability to import that database from law enforcement and monitor for those predators before they get in the park is huge. And again, they have a stadium, you know, they have an event center, so they could really use the product 3 times over. But that's a use case that's not actually listed in the slide deck. But like I said before, your imagination kind of limits how you could use the product itself. Security is definitely one way. Fraud prevention would be another, whether that's in a financial institution and you want to verify that the person who's making the withdrawal is the person standing in front of you is who you have on file as associated to that account. Again, I think the possibilities are endless.
Yeah, Barbie. We're also seeing a lot of activity in schools. Schools, I don't know if you have school districts on your slide deck here, but seeing a lot of activity in public education where they're wanting to verify the parents that are taking the kids out of the elementary school. Is that the mom, or is that the dad? And is the dad a bad dad? He's been divorced from the mom. He's not supposed to be taking the child. And they're also putting in getting the local sexual predator database and putting that in there as well, and giving that overall security for the schools as well.
No, that's another great one. That's actually the end of our slide deck. So I'm not sure if we want to go through the questions that came in during the presentation now and see what we can answer.
I didn't have any questions really come in. If somebody has any questions, feel free to send them in. Yeah.
Hey, Barbie, I had a question.
Go ahead, Dave.
I had a question that came in, and it was kind of in general referencing the VMS systems that you talked about versus the installing cameras from scratch. You know, do you have to buy NEC cameras, or can you reuse? Maybe if you could talk about that a little bit more.
Sure, Jason, you want to take that, or you want me to start with it? Go ahead.
I can handle that. Yeah, so that's the great thing about NEC's Neoface Watch and our algorithm is we'll work with pretty much any brand of IP camera out there. We do have a list of supported cameras. All your major vendors are out there are supported: Bosch, Access, there's Hikvision, Samsung cameras. There's a list of all the supported IP cameras out there. What we We do not support analog cameras though, because we do have to bring this traffic over the IP network and bring those frames in. Where a VMS system comes into place is where most of your sites will have either a Milestone, a Genetec, a Hiowa VMS system. And what we will do with the Neoface watch system, instead of pulling the individual streams from all the individual cameras, we'll actually just connect to the VMS system, and there'll be a one single integration point to the VMS, and we'll pull the video streams right from the VMS system. I'd also add some alerting for your threat alerts or your VIP alerts that'll be pushed out to those VMS dashboards as well. So, one central point to manage all your cameras and all your alerts come in on their Milestone dashboard, for example.
Great. And I actually see a question. It's kind of a standard question I think that we probably get a lot. What happens to people with glasses? What happens with people with hats?
So glasses are not an issue for us with our latest algorithm. We just reproduced a new algorithm that came out, released about 4 or 5 months ago. But now dark sunglasses are not an issue for Neoface to match that subject. Hats, of course, if it's pulled down low on the eyes, it's really low on the face, we may miss that subject coming through. But yeah, if they're covering their face with something like a big build hat or something, they wash that image out, or even just cover his face up.
And then I see another one asking about the hardware requirements. What does it take to actually run Neoface Watch?
So it does take a little bit of hardware. You have on your server, so like if you have a large deployment, let's say 25 cameras, you'll have one server that'll be your database server, and that'll manage all your alerts in your database and your matching engine. And then you have some other servers or processing servers that are just processing the camera streams that are coming in. Each one of those processing servers, since we are doing live video streaming, it does take a lot of processing power, and it also takes a fairly powerful GPU that along with the servers. And each one of those processing servers will handle about 6 cameras apiece. So I see a question here about a shopping center and multiple tenants. So yes, the Neoface Watch system can be tenanted out, fully tenanted, where each tenant would have their own logins, they have their own database, or they could be sharing a database but have their own logins and their own watch list to manage against that database. But yes, the system can be tenanted out for a shopping center type of venue.
And I would think that would be great for some of the larger shopping malls to actually provide that to a service to their tenants, right? So if the mall installed the overall system, they can divvy out those cameras in the tenanted arrangement to where Neiman Marcus only sees the feeds off Neiman Marcus's camera. So it really does open up a lot of opportunities for even the mall renting the space to rent this type of technology to their end user.
Yeah, how many cameras would you like? Facial recognition into your shopping center, or for each tenant, I only want to pay for 5 cameras this month or 10 cameras, or you could definitely build that out.
Absolutely.
Yeah.
Hey, Jason or Barbie, how does the queuing concept work? Right? You talk about queue times and taking. How long does it take a person to get from point A to point B? Because Neoface Watch does that. What's the logic mechanism of how that happens?
It's really just matching that person in the database and just taking the time off of it. But we do have there is a real-time dashboard that we have out at Houston that we deployed, and it shows up some dial graphs and things like that. So when the queue depths do get long, those dials move in real time, and they'll start alerting people when the queue depths get long. But it's really just matching somebody out of the watch list and then marking that time and then capturing in the next camera and then marking that time.
You're basically auto-subscribing in the first camera and then looking for that same subscribed face to show up in a different camera?
That's correct. Yeah, that's correct. So at the start of the journey, that camera is actually auto enrolling subjects in. And then
I think I was going to say one of the key adds to that, at least it's my understanding in the Houston airport, is when they're doing that time logging and they're anonymously enrolling that person as they enter the line, and then when they exit, is that none of those images are actually saved. That at the end of the day, that database is wiped clean. They're not using it for any type of surveillance. They're truly using it as a logging mechanism, so there's no reason to retain the images, and they're just completely wiped out.
That's correct.
Barb,
Yeah,
go ahead, Jason.
No, that's correct. That's exactly right.
Well, I guess that it raises a really interesting use case, right? Because when we are talking about the one-to-one, the one-to-many, and the many-to-many, it assumes that we're interested in an identity. And in this scenario, we're not interested in an identity. Yeah. We just want to know that this random face showed up here, and then 5 minutes later showed up there. And we don't care about who they are. We just want to know how long it took. And I could see some pretty creative use cases, even in the, like at a stadium. I'm standing in line for a beer, and I want to know how long it's going to take to get to the front of the line here, as opposed to going down, to the next kiosk. And it might be faster to walk, 30 seconds and be served in a fraction of the time. But I think it's interesting that it doesn't always have to be related to an identity. It can be completely anonymous, and we temporarily keep track of it and then flush it when it's no longer needed. It's a pretty cool use case.
Yeah, absolutely, and it can be used to move staff around a facility as well, based on that wait time. Maybe for some reason everyone is entering through the northeast end of the complex, but I've got people on the southwest side who are waiting in line 26 seconds. Maybe we redeploy some of the staff in the not used entrance to the used entrance to get those wait times down.
Yep.
So one of the questions that showed up is related to the output of that. And I think, Jason, you kind of referenced it as in with Houston, they've created dashboards that show more real-time environments, but you can also do it historical, right? You could say, hey, here were the wait times throughout the day. And it's really just a matter of, okay, now that you have the data, what do you want to do with the data, right?
That's exactly right. Yeah, the data is all stored there. The reporting is still all there. So yeah, exactly. You can go back and pull months of data out of it if you like. Go check that.
So Dave, unless you see any more questions that have come in, we go ahead and wrap things up.
I think
I
think that works.
Great. Well, I really want to say thank you to everybody who spent their time with us this last hour. I hope that it gave some good examples of how the technology can be used, and that it's not just in that, Criminal Minds on TV use case scenario anymore, that it really has moved into the enterprise, and there are ways that we can mine that information and provide better customer service and better security within our environments. So if anyone has any further questions, please feel free to reach out and contact me. My information is on the screen. And I have also listed the upcoming webinar series that we have.
Is that Jason's dog?
Started.
No, that's not my dog. Not my dog.
The issues from working at home, I apologize. Not my dog, but I apologize. But the webinar dates and titles are shown below. So join us, from everything from contact center analytics to IoT, device as a service, hosted, customer journeys, and we hope to see you again.
Hey, Barbie, you made a comment, and I want to go back to it because it was a really cool comment, and made me think of another really interesting use case scenario. In the fact that because we are analyzing video feeds that happen to be coming from a camera, with NEC's Neoface watch, there's no reason why that video feed can't be an archived video footage. In the class that we took, we'd actually pull movie clips,
movie trailers,
and fed it into the system, and we had the system either auto-enrolling or we were looking for specific actors, and we'd be notified. So that relates to a really interesting, in terms of proof of concept, will your existing video cameras work well? If you have a feed that we can run through the system, then we can find out who we match with that. It's really, I think, amazing use case of not only the testing side of it, but also just going back after the fact and saying, hey, I've got some video footage I'd like to rather than sit there and wait to watch it with a human being, I want to just run it through the system and have the system tell me if they spot anything. So totally apologize, but you mentioned something really cool that made me think of
No, that's fine. And you know what, Dave, I'll also add that we do have demo capabilities within Aerosystems integration. And if it's something that's of interest, we can definitely bring those demo kits to site, for a meeting to run some of that historical footage, however anyone would like to look at it. We'd be more than happy to do that.
That's awesome. So I think back to your concluding slide, we've got a bunch of good webinars coming up. And I think some of these, as I'm looking, are already getting reversed, like the Breeze topic. I think we're going to do the what is IoT before we do the Breeze-based IoT. We've got a good schedule. Our intention is to be at least 2 months out, so what's coming. And so, we'll start seeing some of the April dates populate in. We actually know what those April dates are. We just didn't want to overwhelm you with cool topics coming up. But you can see from contact center analytics to report monitoring and management, Nutanix, the hyper-converged platforms that we have. That's actually another one. This is an old list. The Nutanix one is happens to that's one of our conflicting dates. So February 15th, we're actually not going to have one of these series at all. We've moved the Nutanix one down a little bit more. But you can definitely see from device as a service, all of these as a service and cloud kinds of technologies where ASI is definitely embracing and bringing, helping our customers see the value of some of those different deployment models. So a lot of really good stuff coming, and we encourage you. The good news is it is the exact same login that you came today. Is the same one that we'll use for this. As you probably saw, it created a recurring series in your calendar. So you'll have that, and you can show up when a topic looks good. I would also encourage you to maybe show up if the topic doesn't look good, because it probably means you need to know that topic a little bit more. So I'd, most of these are going to be great and presented by other fellow solution architects. So definitely knowing what they're talking about and having the good experience to go with it. So with that, we are done with our first in the webinar series. Barbie, Jason, Daryl, thank you guys for joining. This will be recorded. We will post it on our website at some point, probably within the next week or two. And we will we'll hopefully see you next time. So until then, thanks everybody. Have a great day.
Thank you. You too.
Thanks.
Thanks.